right. Okay, thanks for being here. Since I came in the US in '98 for the first time, working at Sprint, I've been trying to share data with the community. So at Sprint was pretty permissive. They let me do what I want as long as people would not publish the data in newspapers. That was okay. And many people have used data from Sprint. There was no NDA, there was nothing. People will get BGP, ISIS, everything. But I think it was a different period, okay? Today, even telco engineers or ISPs don't discuss about their network at Nanog. I mean, I remember Nanog AETF, everyone would talk freely about everything. There would be exchange of information. They were all managing May West together, and they would discuss about the management and the performance of the network. I remember an anecdote where Google discovered a bug in a router, and they say, how come do we discover the bug in the router now? And someone said, oh yeah, they know it at Microsoft since 6 months, but given we don't exchange information anymore, nobody from Microsoft told us that there was a bug in this router. So I think we need to come back to a culture of trust and sharing about data. Now, we have a problem, okay? We published a paper in CCR a few years ago about how to work on data with industry, and the answer was basically come as an intern or a visiting professor, okay? There are tons of reasons for that, and good reason. It costs money to have people work on the data set. You have to prepare everything. We had ideas, for example, we suggested to give academics CPU in data centers before they go on prod, okay? And they are there, they sit there for a while. Why don't we give them? But again, everything is as a cost. We need to manage that. So in the end, we never really shared massive data as we would have loved, because it's difficult. Even taking a workload and anonymizing it in a way. I mean, we all know that anonymization doesn't work, and most of the time you remove much more than you would like to remove. And it takes time, and it takes money, and someone has to do it and verify and so on. So it's very complex for industry. And so I know that we have people, Marwan here from Cloudflare will talk about the data that they are giving access to. Well, Serge, I wanted to have Serge talk also about platforms. So they have been doing, or they are doing a huge platform in Europe called Slice. And could a platform provide us the data that we need to do research? And by the way, another question that's related to John's session, I mean, do we need to have the same level of verification on data than industry? Okay, why do we force ourselves to validate a new algorithm or a new AI agent on 1 million users in a real network? No, I mean, we are researchers. We could validate on an artificial workload or data set, and then that's the job of the hyperscalers or the cloud providers to verify on their own network. So that's the kind of discussion I wanted to have here. Jim told me that Ramesh, are you around? No, apparently Akamai just made available artificial workload, I mean a synthetic workload for people to work. I was hoping you would come to the session, and if I see him, I will call him to talk about that. But that's another approach, okay? So who wants to start? Serge, Marwan? Serge? Yeah.
I am warm because basically I was in the previous session in this room, so I'm going to repeat myself a little bit. What Christophe was saying is that the world is changing and the way we do research certainly is going to be affected. First, you certainly observe a deluge of papers. This is triggered by AI/ML, plus 20% at SIGCOMM' this year, to be checked. Second, still no progress over the 20 last years with respect to reproducibility, meaning do we trust the research that we produce? And third, I forgot third, but basically, third is that if you want to do research, third is obvious, so obvious. I do this exercise every year to support the SLICES initiative, where I do account the number of papers published at SIGCOMM'. I remember a dispute with Christophe, where I just account for the number of papers published by at least one author from the big tech. And you see the trend, very, very interesting, and this trend is accelerating. This year, 60%. 11 papers from Alibaba, 11 papers from ByteDance, as many from the big tech in the US. And you see that the number of authors per paper is increasing as well. What does it mean for academia? Does it mean that the cost for doing research and being competitive is increasing? And again, it's not opposing to industry. Industry has a roadmap, of course. It's not arguing that we need to scale to what industry is able to scale. It means what should we do as a research community? So when I started to prepare this SLICES initiative, why is it different from others in the past? Because it's designed as a scientific instrument. So in Europe, we have a process which is highly competitive, very complex, very lengthy. For instance, if you want to build a telescope, or if you want to build a collider, it costs about 4 to 5 billion euro. It's a very competitive process, but if you look at other domain science, not claiming that we are worst, but they use scientific instrument as a mean to produce meaningful research that provide ground truth. So 90% in this domain, 90% of the scientific papers published are using scientific instruments. So again, what we are just trying to do with SLICES, which is the first scientific instrument in digital sciences, is to support the full research life cycle. So meaning that having access to infrastructure, but also having access to data, because without data, there is no AI ML, there is no foundation model, there is no agentic AI. And it really creates an even bigger tussle with respect to the academic community. So yes, how can we have access to that data, knowing that there is a big tussle between openness? So for instance, if you get public funding in Europe for doing research, you are supposed to follow open science. Open science principles means that you need to publish in open science venues and you need to release the data. This is a big tussle with respect to industry, where of course competition is key and usually you don't want to release data. So if we want to do research, for instance, in foundation models, then we need to have access to data. And then it's becoming a big issue with respect to the way academic can work. So basically, SLICES is aiming to become a repository for open research data. And so we welcome any data that even industry will be able to release so that it becomes basically a reference infrastructure for testing different assumptions on a given problem.
I thought SLICE was also federating platforms.
Okay, so the way SLICES is designed, again, is the responsibility of the research community. The beauty of it is that we have a support until 2042, meaning that we don't have to design an infrastructure with financial support for the next 3 years, where we need to demonstrate that we provide access to academia, to industry, to SME, that we provide training, and so on and so forth. So the fact that we have 20 years, it changed really the way we can design it. And then, of course, we now challenge the community with respect to what are the main scientific questions. So, for instance, I had to argue with this umbrella in Europe that is basically providing the funding for those scientific instruments. And you have to talk with high-energy physics communities. And the first question they ask you is, what is the scientific question that you want to address with this scientific instrument? It's much more difficult for us. For them, I always take this example, they said, does the Higgs boson exist? They go to the policy makers and the funding agency and say, does the Higgs boson exist? Give me 5 billion, I will build a collider, and I will eventually demonstrate that the Higgs boson exists. Okay, but they are all united. You will not see someone from high energy physics in the Netherlands saying, oh, no, that's not a good story. They don't care. Do you think that they all work on the Higgs boson? No. They basically use the scientific instruments to develop their own research because they need this to demonstrate different kind of evolution in physics. Is a collider much simpler than a system that we address in networking? I'm not sure. You know, they're very advanced technologies, likewise for telescopes. At the time of COVID, because there is this other argument that, you know, data is very complex, you need to anonymize, blah, blah, blah. Remember COVID was not long ago. It was very competitive because everyone was trying to design a vaccine. The academic community succeed to share the data. Basically, in a month, they agree to share the data. Okay, so I always see that, yeah, there are a lot of good examples to argue that, no, we cannot share data, we cannot share infrastructure, but actually I think it's really a responsibility of the research community.
Okay, thanks, Serge. Marwan, do you want to?
Sure. I'm happy to talk about radar, but I actually have a comment on this one, which is interesting. So
Marwan, from Cloudflare?
So I'm Marwan. I'm at Cloudflare. Before Cloudflare, I was an associate professor. So I speak, you know, my heart still lives here, but of course my body and mind are elsewhere. So first, I think I want to, this is really interesting what you said, but I think it's important to acknowledge some differences, and then I can talk about radar if anybody wants to, and some of the challenges that we face with radar. I've always marveled at the physics community and the way they can band together and they get all kinds of resources and so on. But at the end of the day, the Hadron Collider is funded publicly, some sponsorship. It is not a for-profit endeavor. You know, we work with a bunch of organizations that employ people that, you know, have to make money and the shareholder, all that stuff. And so I would suggest, and I don't know if this is right, but they are able to produce the data and share it so that we can know things. Most of the companies that run the internet today have real constraints, part of it related to liability that makes them worry. However, what about the NRENs? I mean, a question that should persist is, why don't the NRENs record traces or log, and all of it comes back to the money that Christophe is talking about. It is not cheap to run an endeavor like this, to the logging and the recording. But I've got to be honest, if the NRENs, like Géant and Abilene and Internet 2, and right, these are gold mines. So short of money, what's going on?
I was going to answer the earlier part. I don't have an answer to that part.
All right, fine.
But I'm going to use the fact that I'm still at the front of the room from the last session to advertise a new data set that we're making available that is somewhat along the lines of what you're talking about.
Okay, this is Ethan, by the way.
I'm Ethan. I'm from Columbia. You may have heard us in the news recently. So one type of data that I never thought I would have access to or the ability to share is traces from residential networks. But Columbia is in New York City. Academia doesn't pay that much, so the only way that we can afford to live there is for Columbia to give us housing. And they also provide internet to all of the buildings except for mine. And they've, so this is about 8,000 apartments in New York City, housing Columbia faculty, their families, graduate students, postdocs. And we now have a continuous data feed from 1,000 of the units. We're going to work on scaling it up to 8,000 as I mentioned, luckily doesn't include my data, and we're allowed to share the data with people. So this is packet level traces with privacy protection on it, and we had a paper about the data set at SIGCOMM'25 this year, and we would love for other people to use it because my students spent a lot of time setting up the traces and figuring out how to affordably store them, somewhat along the lines of what Marwan said. We're currently getting threatened by Columbia IT because one of my students uses more Google Drive space than like the rest of the campus combined or something. But yeah, please use our data, reach out to me, or we have a website, maybe you can find it, or look at our SIGCOMM'25 paper and email my student.
Yeah, that reminds me that when we were doing anomaly detection with Jen, we had a huge data set annotated by hand. All papers using it were rejected because the anomalies were too old. Okay? So we don't have a culture of benchmarks. And I'd be happy for people to reuse your trace, but I don't know if we're too tough or what, but we don't have that culture of benchmark like the video community, you know, where they still have the picture of Miss World. No, the picture is, no, but you remember that picture. I don't remember. Lena? Yeah. So they were using that as a benchmark for years, okay? We never had anything like that in networking. It's very difficult. We don't have that culture.
Short answer to Marwan, it's not in the mission of the NRENs to do that, for instance, for Geo.
Yeah.
Because it costs a lot, but it's in the mission of the scientific instruments. So a collider has a mission to store the open research data. And you know how much data they produce per day? Much bigger than what you think.
Okay, so maybe that's a place actually we can collude. And Christophe asked me to talk a little bit about Cloudflare Radar. Can I just show of hands who has heard or knows about Cloudflare Radar? Wow, I'm always amazed by this. And so I was going to say who's used Cloudflare Radar, but given 4 hands went up, there's probably no point in. Okay, 2, 3, 4, maybe the same 4. I guess when you know about it, you can't help but use it. So if you go to radar.cloudflare.com, there is an enormous amount of, let's call it observability, data about the internet as Cloudflare sees it. Is this recorded? Have we figured that out? So I will say, when you walk in, please don't perceive that as being the internet. I even have to remind people at Cloudflare that what's on Radar is not the internet, it's Cloudflare's view of the internet. Cloudflare, I think, has more interconnection than any other network on the planet today. I would wager it's no more than 2 AS hops from, I don't know, 99, 98, 95% of the planet. Clearly that's not the internet, okay? But what it does see is still valuable, and it posts virtually everything. Everything that Cloudflare can think of to put on the website goes on the website. If it can be produced in aggregate, and if it can be automated. Because the team Radar, I think it's about 10 engineers or so, and you add up the salaries and you add up the resources and the storage and the query processing and so on, it's not a small cost to the company. So Christophe said, why would Cloudflare do this? And the shortest answer, I genuinely think, is about trust. It's about generating trust. Yes, there's no doubt that the company gets kudos and trust in the company. Absolutely. Let's be honest. Everybody acts out of self-interest. In fact, Stefan at IMC a couple of years ago gave a great keynote, and he said, if you want to work with people in industry, you need to understand and acknowledge their needs and their constraints and respect those so that everybody wins. It's not a one-way game. Okay? So Cloudflare benefits with Radar, but at the same time, the internet is benefits. And I genuinely, people at Cloudflare will say this, one of the reasons to do this is so that people can better understand the internet, start to trust in it, have answers to questions, make it so that it's not as opaque as people perceive it to be. And on that, there are 2 anecdotes I think that are worth raising, just as evidence of the returning trust. One of which a few of us talked about a couple of years ago. Anecdotally, the observability that is available on the internet is slowly disappearing. So talk to enough network operators and they will tell you ICMP is decreasingly Over time, it's being disabled more and more within a network. So if you launch an ICMP probe of any kind into a network, you will get no response back. It will be black holed unless you're inside of the network. Big boo, right? And okay, fine, we can understand networks want to protect themselves, but this cannot be the way to do it because it just makes the system more opaque. We can't see it, we can't investigate it, we can't trust it. It's gotten so bad, in fact, so we've been working on mechanisms to detect carrier-grade NATs in the world. And on a personal level, this is very important because I know definitively that carrier-grade NATs, their distribution, their physical distribution in the world, follows socioeconomic lines. You come to the internet later, you have less IP space, you're more likely to deploy a carrier-grade NAT, which in principle is fine, that's why they exist, except that when you're something like a carrier-grade NAT, you produce a higher volume of traffic than most other IP addresses in the world, and so you might make decisions or judgments about the sources of traffic that are not actually representative of the traffic that is being generated, okay? So, if you reach out to the operators, even as an operator, and say, hey, can you tell us where your carrier-grade NATs are so that we can do the right thing and not penalize people? They won't answer. They won't say no, they genuinely will not answer. And if you give them a set and say, here's what we think are your carrier-grade NATs, will you just even confirm? They will not answer, by and large. And I agree with you. That is something, I don't know how to correct that to convince more and more operators that it is okay to share information about their systems, and the way to protect them is by being transparent. So anyway, as far as radar is concerned, it's all aggregates. There's an API. You don't even have to look at the website. Some people get rate limited. If that happens, you can always send an email as a researcher and get unrate limited. If people want data or have ideas for data, I will happily entertain them. I'm always reticent about putting people like, oh, that's so cool, we should put it on radar. If it can't be automated, I won't put it on radar. And on a personal level, one of the things I worry about is how data is represented. So the data alone is not enough. We've been doing sort of these resilience measurements for different regions around the planet, and there's a lot of pressure to publish this on radar, and I've been a hard stop, and a couple of others have too, thankfully, because I worry, and I'm sure Fabien is talking about this in his session, I worry sometimes that the way we represent data hurts the internet more than helps it. So when we do this along country lines, for example, or border lines, giving the impression that the internet somehow can be controlled or has these partitions, and so people in the world say, oh, well, I can treat them like I treat the telcos. And I don't think that is helpful for this. So we need to find new ways even to take the data that is available and represent it.
Okay, thanks, Marwan. Any comment? Anyone in the room who wants to who has an opinion on the topic, or who needs data, or we have an opinion about should we do research with data or just abandon the idea, work with artificial data? Another thing that I think rocket fuel, I don't know who is old enough to remember the rocket fuel paper. And I mean, these guys were, I love the method, okay? At the time, the Sprint, the AT&T, they didn't want to publish anything about their topology. It was super secret, competitive information, and then rocket fuel came, and they inferred everything. And they sent an email to Jen and to me, and they say, what do you think of our topology? And we answered, wow, not bad. And with that, they went to SIGCOMM'. The paper was accepted, and they said that the results were verified by AT&T and Sprint, which was a little bit too much, because we had just spent 10 minutes with Jen looking at the overall topology. And you know what? It worked. After that, Sprint and AT&T, they stopped, because they realized that that can be inferred, the topology. And maybe we can do that too with public money. I don't know if it's the job of public money, but just buy space in the different cloud providers, CDNs, and start running workload and share the data with researchers. I don't know if it's going to be very useful, but I'm personally not optimistic about industry sharing more data in the future, okay? And I think that we might need to go back to more benchmark culture, where we have a couple of data sets that we trust, or We might have to work on synthetic data. I don't know who has been working on generating synthetic workload. Is it still a hot topic or in research? Or no? What about IXPs? About what? IXPs. IXPs, yeah. Who talks to ISPs a lot? IXPs? Okay, I don't know IXPs. I have a friend working for INXP. He told me that they are construction companies, okay? They build exchange points. and they are not too much into understanding the performance of the internet. But, you know, I've been pushing for MLab to deploy data center servers in IXPs because I think it's a great location, okay? That's where you see all the content today. I mean, most of the interesting content goes through IXPs. But, okay, any comment, anything? We can finish the session early. Oh, no, not Anya.
You talked about IXPs, and so I guess I'm working a lot with some IXPs, and in general also ISPs, and a lot with data that is not necessarily publicly available. And in some sense, it works for me because I was able to establish a trust relationship with the people that actually are the owners of the data. They trust me that I treat the data as if I would be in the company and that I'm not saying something about the data that is not supposed to go out, that I check with them. If in doubt, I won't do things with the data that in principle could be done. Such a trust relationship is really what makes a lot of the stuff where we work with companies work. Now you ask, how can you establish such a trust relationship? How can you get to the point that some people ask you, hey, I have this kind of data. Would you like access to it? Which has happened to me in the past and which I've highly valued. It works because I started myself slowly. As I was a grad student, I actually read some paper by Vern Paxson, etc., and they were like, hey, there's this long tail stuff, there's this self-similarity stuff, and I was a grad student doing theory, and I was like saying, hey, does this worst-case analysis actually make sense? And that's when I started doing my first packet data collection by going to our local IT support and ask, can I gather some data to analyze? And honestly, getting that kind of experience, getting your hands dirty, really playing with data is a key element. So even if you just do it on your own internet traffic that you yourself send, that's already one step ahead in terms of understanding what is in the data, what is not in the data, what is the messiness, checking if you actually got all the data that you're supposed to be getting, making sure that you're actually recording all the data, that you're not falling into some of the measurement pitfalls. And I think it's actually important, if you want access to data, that you actually did something on your own first, be it with simulation data, be it with whatever. But get your hands dirty before you go to others and say, can I get your data? Because then it's going to be much easier once you've shown that you can actually do something with it. Now, why don't we have benchmarks? Difficult question. One of the things is things do change all the time. And so getting an attack data set from 5 years ago, where you only have attacks but no benign traffic, that's probably not going to work, depending on what you're looking for. So understanding the data that you have available at your fingertips and whether it's actually usable for some kind of analysis is as critical. When you want to use an LLM to actually test whether it can do attack detection, well, think twice if it's actually feasible to do that on that data set, or if it is fairly obvious that it will work. Know what is feasible, what is not, know your limitations. And before you do the work, ask, hey, what am I going to learn from it if I do it? Because if you cannot learn much from it, you better not do it. Anyhow, just some thoughts.
Thanks, Anya.
If I can be a little bit controversial. Of course, Anya, you know me, I trust you. Okay, so I trust, of course, the paper that you publish with your data. But assume that now I got a paper which is addressing a problem, trying to optimize whatever type of function. We did it in the past using some, let's say, methodologies. Now I'm using ML. Okay? All of a sudden, the results are always much better than what was done in the past. I don't have access to the data, I don't have access to the training, I don't have access to the model. Should I trust or not? Very simple question.
No, but I think not most of my paper, but many of my paper would never have been accepted if I had to share the data, okay?
But I trust you too, Christophe.
And that's sad, okay, because we don't have this reproducibility of our research, but I don't know if there is
But now you have a lot of those papers with the IML, so what do you do?
Yeah, I think we should use AI to generate data sets.
Oh, that's going to be a contentious one. I'd love to hear the end of that one. So I don't know how we are on time, but I think it's always useful to try and identify paths forward. And I actually wonder if, there are two concrete things that we can try and do. One is, I'm sure many people in the room have gotten the sense that somehow the reviewing and the feedback process is a hot topic this year for many reasons. I think I will briefly summarize and say, this is forever true, but every now and then maybe it's useful to remind ourselves that we are not gatekeepers of knowledge. We are, when we're reviewing, shepherds. So it's not our job to police. I think it's more a job to find ways to put information out so the community can help judge. That's the first. The second is related to data. There's going to be, is Craig in the room? Partridge? Too bad. So there's going to be a paper, I think it's one of tomorrow's sessions, called Sierra something, and it is how the Scion network has become an academic, like an NREN, a global NREN. Similar to like a Planet Lab type thing from ages ago, except now it's layer 3 and it's about interdomain routing and it works and it's bare metal, it's not an over IP. I know there are people in the wider community that are a little bit threatened by this, feeling like Scion is trying to replace BGP, and I don't think that's true at all. I think it offers things that are really important and will actually help the survivability of the internet that we have. Having said that, if the Sierra thing is, show up as a community, look at it, judge it, scrutinize it, it's got access points all over the planet today, maybe, given that it's this educational thing to start, it is a good starting point to start collecting data now. I don't know if the insights that we draw from it will be the same as what we would draw from an IP internet, but it is a place I think that we can, from the ground, from the inception, we can start to think about what kind of data do we collect, how do we record it, how do we share it, what are the sensitivities?
I have a question for people here. Who would be in favor of accepting only papers with their data and the code? Okay. I suspect that all people who don't raise their hand, it's because they are publishing papers with data and they cannot publish the data, like me. So the other question is, because that's something we tried at Sprint, it's difficult, but what about making your data available through you to other people and saying, okay, I'm going to send you my script to verify your results on your data. So you claim something, I send you my script, or I send you my code, and you can compare so that I can publish multiple data sets. Would you think it's feasible? Would you like something like that? That's a way to share artifacts, okay? Yes? No? Yes? Okay, nobody thinks it's a good idea. Good. What? You don't see the data. You keep your data. I mean, I have my data from Google. I claim something in a paper. You will tell me, okay, I want to verify. I will write the script. I mean, that's an old idea we had with Vern Paxson long time ago. It's encourage people to reproduce. Today, if you publish twice the same paper with a different data set, likelihood is you will be rejected because you do the same thing twice. Okay?
Hang on. There are some reproducibility tracks, etc., where it's actually okay to do exactly that. IMC is going down that road. There are some.
Not at IMC, not at SIGCOMM'.
Now, you were also asking the question about who wants that papers can only be shared if the data set is being made available. I actually have the other point there, and that is, shouldn't papers only be accepted if the code is being made public? Because a lot of people require or kind of always ask for the data sets, but then if you ask them, hey, what about your code? They say, no, we cannot publish that. And if we go down that road, we need to actually do both. But the other point is, the internet is so complex. Something that we may observe in one location may not be true in another location. And in some sense, if we really want to kind of confirm results, we have to get independent people to actually look at independent parts of the internet and get the similar results. And I think this is actually going back to some of the things that we learned about earlier. If you look at the Higgs, that is what they did. Two different infrastructures finding the same things. And as such, part of actually understanding what is going on means doing the same thing, and we need to get people credit for it. And I think that is actually one of the things where in the community we may have to change. It's not just about sharing data, it's not just about sharing code, it's also recognizing that confirming results, going back after 10 years to check, do these assumptions still hold? Questioning assumption is actually critical.
Yeah, the model is you have a data set, I send you my code and you run my code on your data set and you check for me and you just send me the results. And one of the questions I know is one reason why it was not in our paper as on CCR as a way to collaborate with industry. It's because you need someone to verify that the information returned contains only what you need and not additional thing that could be a problem for our company.
Can I add to that while I pass off the mic? Is Zakir in the room? No.
What?
But
Sujata? No? Enya?
no, there was a hand over here. I'm going to pass off the microphone.
Ah, Marijo?
But,
Who had a question?
But so Zakir this morning made a comment about it's not just anymore that what you described, but there's also a problem of the source. This comes back to the trust comment. It's really hard to validate the source of the query.
Well, I can think of an awful lot of data that we need that cannot be generated by code now, because we need historical data that was generated years ago. We need data that was captured during a snowstorm because we're trying to do ray tracing. We need to have, well, you can have a digital twin if you want, yes. Okay, if you want to have a digital twin of everything, you're going to be able to generate the data and then email me your digital twin and I'm going to maybe redo the data, but it will be artificial. But what I'm saying is that just sending a few equations to generate the code, that worked when I did my PhD, but I don't think it works now.
I think, so I'll try and be controversial here.
Well,
if I may.
maybe, and
Yeah, I'm actually, I'm having, we're 3 minutes?
Yeah,
Okay.
and
I'm finding this fascinating, the idea like, if I stand up with a Cloudflare hat and say, I will welcome queries to submit against Cloudflare's database, that we have a problem with that? And I want to understand what that, I mean, there's a scale and there's a security, there's all kinds of things that are issued, but like what is genuinely the problem of the people who are writing the query to get the results back from data they cannot touch?
So the problem with that is that people will try to game the system. So the problem is code that you haven't checked will be able to actually extract information that should never go outside, which is part of the reason why some of these things are difficult to do. Now, for the work that I do, I honestly say, if there are questions about some of the data and some of the things, I welcome people to come as visitors, as interns, etc. And then we can do the joint work. But then I want to have some proof beforehand that they actually mean it seriously. That is going back to the point that I made earlier, establish trust that you can actually do data evaluations.
Why is it the problem of the person submitting the query? That should be my problem.
No, it's actually, hang on. We have a scalability problem. And that is, if you say, I do have data, I accept any kind of queries that are coming in, that is the problem, which is why you probably want to do that for trusted parties, but the question is how can people establish trust? And that is how can somebody from an unknown university, an unknown grad student, an unknown undergraduate, how can they establish that kind of a trust that you would actually run their code against your production data to make sure that you're not revealing something that is not supposed to go out? And data leakage can become a problem.
So let me offer I agree with you 100%, and I'm very much in that camp. But let me say we are computer scientists. If we are talking about submitting, we can develop tools. We can define constraints and requirements. We can build verifiers and do all kinds of interesting things, I think, to make that situation more scalable. Whether it's enough, I don't know. But maybe it is worth entertaining. How do we make it safe for people to submit queries against data they can't touch?
I think that's actually important, but that's a research topic that we've been trying to tackle for quite some time. Now, the other part is, I would be already very happy if the papers that are being submitted to conferences such as SIGCOMM'25, etc., would at least contain enough data so that I could actually understand the experimental setup and have enough information that I would be able to actually find out what simulation did they do, what workload did they use, what are the basic principles of that. That would be already a huge step forwards in terms of reproducibility.
Okay, thanks, Anya. Do you want to talk? No? Quickly.
No, my only comment was I agree with that about the reproducibility of paper, that also we should maybe consider that as, I don't know, training or agreement when we're all reviewing papers, that's a criteria, like how reproducible is your paper in the way that you describe it. And the other thing is, at least the reproducibility track at IMC, a challenge that it is, even if you submit there, in the expression of interest request, what are we going to learn from this reproducibility? What is the novel things that we're going to, it's like, okay, then there's a novelty in there. So if you do exactly the same experiment 10 years later and you get the same results, your paper won't get accepted.
Okay, so as expected, we didn't make any progress. No, it's a good discussion topic, but I'm sorry. I mean, I don't think enforcing sharing of data or code should be okay. Source code should be okay, but for data, I think it's crazy. And someone mentioned digital twin. I think it's an interesting venue, but the cost of a digital twin is pretty high. I mean, we're working on we have today we can run a duplicate of our network in Kubernetes containers using the real code provided by Arista and all these guys, Cisco, Juniper, and we can build huge network with that and run experiment. I mean, not control, management, not data pass, okay? Because it's very hard to generate. But maybe we can build benchmark with that. Okay, thank you very much. Thanks for staying so late with me instead of going to have a beer with friends. Okay, see you tomorrow, guys. And thank you.